Good evening. My name is Ridwan. For those who are just joining us for the first time today. Okay, so welcome to DataFrames program on data science fundamentals. So today is the day 3 of this series, and we shall be discussing introduction to Pandas, creating data frames, and reading from files. Okay, so to quickly recap what we discussed the last time in the last class, that was last Sunday. So the discussion centered around more on NumPy. On the first day, we discussed introduction to NumPy, and the second day, we discussed further on NumPy. So we discussed how to create random arrays of array of random numbers. So for instance, in this example, we're creating array of random integers between 0 and 100 of shape 4 by 5. So I will print out the array. So my kernel is just connecting. So as soon as it's connected, it's going to print out the array. All right, so there you go. If I were to repeat this operation, we're going to get different sets of numbers drawn between 0 and 100. And there you go once again. So we also discussed indexing and slicing. So in this example here, we're trying to get the second item. I'm talking about the sub-array in the main array. So I'm referencing the array that was created here, the random array of random 4 by 5 array grid. So in this example, so we want to get the second item in the main array. So keep in mind that the second item is going to be a sub-array because in itself it's an array. So that's the first example. In the second example here, get the last 2 items in the sub-arrays of the second and third sub-arrays. Get the last 2 items in the sub. Okay, I think there is, I didn't frame this correctly. Get the last 2 items in the second, yeah, I've corrected, in the second and third sub-arrays. So in the second and third sub-arrays, get the last 2 items. So we want 14 and 65, then 31 and 12. In the first example, we want the second item, which is the sub-array in the main array. So we want this in the first example. And in the second example, we want 14, 65, 31, and 12. So let's check this third example. I think I put them, have I listed this correctly? Second and third. Get the last 2 items in the second and third sub-array. Okay. So while I was preparing the notes, so it was the output that was printed that I put here. So I'm going to take it off now. I'm going to take it off now. Okay. So hoping that is going to be clear. So I'll do the same here. Okay, so here, we are to get the first and last items of all the sub-arrays. So we have 4 sub-arrays here, 1, 2, 3, and the last 4. So we have to get the first and the last items of all the sub-arrays. So here we want 57, 5, 23, 65, 7, 12, 86, 29. So now let's print all and verify that we have all we wanted. So in the first example, we got 23, 59, 93, 14, 65. In the second example, last two items, 14, 65, 31, 12. Here we have that. And in the last example, we get the first items and the last items of each of the sub-arrays. So here we get 57 and 5. Here we got 23 and 65. Then 7 and 12, then 6 and 29. Okay, so another thing we discussed was universal functions. And I said universal functions are functions that can apply to all the items in an array. So they can apply to all the items by an operation called vectorization, so or broadcasting. So it's called vectorization or broadcasting. So where an operation can be broadcasted across all the items in the array. So in these examples, example 1, we are printing the array and raising it to the, we're getting the exponential of each item in the array. So exponential is like 2 point something to the power of that each number. Okay, so in the second example, we're adding the array to itself. So here as well, we'll find out that each item will get added to itself. Each item, each corresponding item, for instance, row 1, column 1, gets added to row 1, column 1, row 2, column 2. So we're basically going to have the array multiplied by itself, multiplied by 2. I beg your pardon. So in the third example, we're squaring the array. So let's print it out. And there we have it. So this is the first, where we are trying to get the exponential of each of the item in the array. And in this example, we are adding each item to itself. So to verify, this is 114. Let's see what the first item here is. It's 57. So 57 plus 57 is 114. The last is 29. 29 plus 29 is 658. So let's see it. Yeah, 58. So we have 58. So, and here each item gets squared. So here is 49. I'm sure it was 7 that was originally there. So 7 squared is 49. So, and the last revision, or the last revision of the previous class we've taken is this. So here, some array attributes and methods. So we have 4 attributes here: dtype, reshape, then shape, then flatten. So some of them are attributes, while some are methods. So a dtype is an attribute, reshape is a method, shape is an attribute, and flatten is a method. So we see each of them here, and I simply print it out. So dtype returns the data type of the array. Shape returns the shape of the array, which is a 4x5 array grid or matrix grid. And here we're trying to reshape the 4x5 matrix grid, which has 20 items, into a 2x10 matrix grid. So, and we get this. So now let's try to see what it looks like compared to the original array. So I'm going to do something here. Print array. Then print array.reshape 2,10. So let's compare the two. So let's see how things get moved around in reshaping it. So here 57, 80, 78, 54, 5, and we still get the same. So basically, it just gets the second, it just tries to, it goes to the second row and tries to merge it to the first, and on as the shape demands. So here it basically took this second and concatenates it to the first item, and it took the last item there, concatenated it to the third item there. All right, so I won't be entertaining any question from the previous classes. This is just meant to be a revision. So going to today's discussion, we are taking introduction to Pandas. So we'll be discussing creating data frames, reading from files, and we'll also discuss creating a bit of visuals with Pandas. So visualization with Pandas. Or let me say plotting or chart plotting with Pandas. All right, so Pandas, what's Pandas? Pandas is one of the most useful tools you will use as a data scientist. If for any reason you have ever tried to go online and search for, okay, what are the things I need to know to become data scientist, you're sure to have come across the Pandas as one of the tools that will be listed out that you should know as a data scientist. And that is because it provides a very flexible, powerful interface for manipulating, transforming, reading, and doing a host of operations on tables. So it's actually, since most structured data are represented in tabular format. So think of somebody who sent you an Excel file of records. So the file is likely going to be in a tabular form with columns and rows. Or somebody sends you a comma-separated value file, CSV for short, or you're trying to read from a table of structured data such as SQL, structured query language. So an SQL table, for instance, a relational data or other relational databases. So reading from such environments, so you're going to get tabular data. So you need a convenient way of manipulating such data. So while NumPy gives us speed and a lot of things, okay, just a moment, please. I need to fix something up. Okay, sorry for the short break. All right. Okay, so that's a little bit of overview about Pandas. So it's also important to note that Pandas is fast. It may not be the fastest, especially when you compare it to NumPy, but it is considerably fast for most things you would need it to do, especially as a beginner or as an intermediate data scientist. So for most of the things you will need to do, Pandas is going to be fast enough for it. All right. Now, in this program, we will cover the essentials of Pandas that includes installation, data ingestion, and some functions for transforming the data. We will also take a look at how it works with Matplotlib. I'm talking about plotting rather here. Okay, so the first thing is installing Pandas. So if you've never used Pandas on your computer before, chances are that it is not pre-installed. So you will have to pip install it. So you simply launch your command prompt and you type in pip install. Alternatively, you can run it from this Jupyter notebook environment. So I left a path here that you can use to run it. So you simply uncomment this. For instance, leave it as is. I've uncommented it now, this part, and you run this cell. So it's going to install Pandas if you don't have it installed yet. All right. Now, we've been saying Pandas is convenient for manipulating tabular data. So now let's see the basic structure of a tabular data. So a tabular data looks like this, and we have column, and we have columns, and we have rows. So this is what a data frame looks like. Now, what are the operations or the ways we can read and write tabular data? So tabular data can be read from a variety of sources. Yeah, Pandas provides support for ample different sources that you can read from. So think about comma separated value file, Excel file, packets. It's not quite common. So then HTML. So think of, as we'll see later on, a website like our reference Worldometer or NCDC, Nigerian NCDC website. If you go to the homepage of the website, you will see a table of reports of the cases of COVID-19 in Nigeria. So say, for instance, you want to read such data without having to bother yourself so much. Pandas provides a very convenient method for achieving that. So there's also HDFS file. These are more like Hadoop files. Then we have JSON file too. JSON is more like dictionary. So when dictionary data is stored in file, so it's called JSON. So or GBQ or SQL as well, and a couple of others. And you can as well write to all these formats. So each of these formats that you can read from, you can also write to those formats. Okay, so in this, the examples we'll be taking, we'll take examples on reading from Excel, reading from CSV, reading from JSON, and reading from HTML page. All right. So in this first example, we're reading from an Excel file. So Pandas provides a read Excel method as written here. So you simply, okay, the first thing I'm supposed to do, I've not done that yet, so is to import Pandas. So I beg your pardon, I missed that. So as usual, import Pandas. I can import it like this, or I can give it an alias. So for convenience, we usually give alias to modules or libraries when they're imported. So I can simply call PD rather than writing Pandas in full. Okay, so PD does read Excel, then I pass in the path I want to read it from. So in this example, my file is stored in this downloads directory. So, and the name of the file is this. So I simply pass it in. But you'll notice that I have R starting the directory where my file is stored. So I'm going to run this without this R. So we'll see what problem it gives before we'll try to fix it. So let's run it and see. All right, so it says syntax error, Unicode error. Now, what this error is telling us is it says codec can't decode bytes in position 2, 3, blah, 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 escape. Now, this backward slash or forward slash, I don't know what to call it. So now, it is an escape character in Python. So it is used to tell the code or the interpreter to ignore certain rules. So, but in this example here, we're not telling the interpreter to ignore you here. So it's simply the path to where a file is stored. So, but because Python tries to interpret it as that character that tells it to ignore something, so it doesn't function as supposed. So in order to tell Python to ignore that rule, so we simply pass R here or write R at the start of the directory. So this R is going to tell it to ignore this escape character. All right, so this is going to work fine now. Wait for it to load. Excuse me. So Excel files are typically slow to load. So if in your course of doing data science, I will advise that as much as possible, you should work with CSV files and not Excel files. So Excel files load quite slowly. All right, so the goal is to read in file, to read in the table, and here we have it. It has a number of columns. Let's see, if we go to the end of it, it has 25 columns, and it has 9,476 rows. So there are 476 rows of data and 25 columns of data. So, and Pandas nicely formats it for us, as we can see. However, the moment you decide to display this by calling print function, you lose this beautiful formatting. Okay, so it doesn't take forever to print it out again. I'll just simply create, print that in the list. So we lose the formatting, the beautiful formatting that Pandas gives us by using print function. So you'd want to avoid using print function if you want it nicely, if you want your table nicely formatted. All right, so in the next example, we'll see how to read from a JSON file. All right, so there is this limitation with Zoom for those that are just using the Zoom platform with us for the first time. Because we are using the free edition of Zoom, we can't stay beyond 40 minutes at a stretch. So we've spent about 28 minutes already, or I would say 30 minutes already. So in about 5 minutes time, we'll need to cut off and join back using the same link. So the only thing we need to do is I'm going to end the meeting, and we can just join back almost immediately. So, however, should we encounter any technical issue and I'm unable to set it up immediately, I'm immediately going to send an update with a new meeting URL that we can join with. Right, so can I get confirmation that we got this message?
Yes, please.
All right, thank you. Okay, so the next example. So keep in mind that these files, I have them stored on my system already in certain directories. And in this example, is in downloads directory. So I'm reading file from JSON, or I'm reading a JSON file. So I want to show us what a JSON file looks like. So I'm going to just a moment, please. Okay, yeah. Okay, I can't quite locate this immediately, so we'll simply move on. I wanted to show us what. Okay, anyway, I can still do that here. So I'm going to read, before reading it as a tabular data, so I'm going to show with open. All right, so this is what a JSON file looks like. So you see, it's just like a dictionary. And this is how it looks. So with keys and values, keys and values, keys and values, keys and values. Okay, so I'm going to put a heading. So now let's read it as a data frame. So there we go. You see, from looking like this, we've read it as a data frame and it looks like this. So that is what Pandas allows us to do. All right, so considering another example, reading from CSV file. So I just got notified that in 10 minutes, this meeting is going to, we're going to run out of our 40-minute time limit. So maybe 5 minutes from now, we will cut it off and resume back immediately. Excuse me. Okay, so here I still provide the path to the CSV file I want to read in, and I don't forget to escape it with R, and I call pd.readCSV. You can see the functions are actually the names are I think they are quite intuitive. So you are trying to read a CSV file, simply say pd.readCSV. It makes it very easy for everybody to remember that. You want to read from Excel, read Excel. You want to read from a JSON file, read JSON. So very, very intuitive names, very thoughtful of the developers that created the package. So here we read another data as comma separated values, and we get it as well nicely formatted. If we go to the end of it, we see the number of rows, 9,476 and 25 columns. So the last read operations we are going to discuss is reading from HTML. So reading from HTML, so it's actually a very powerful tool. Just a moment, please. So in these examples, so this HTML page, for example, I'm going to open a new tab and we'll try to view what the data in the URL looks like. So while it loads, I'm trying to rearrange some of this. Okay, so I'm covering two examples. The first example here is the example on Pandas documentation. Welcome back.
Thank you.
Okay. So we stopped here. So I was trying to show how the website FDIC looks, what it looks like. So this is what FDIC website looks like. It has a table of records that we can see here. So we're going to try to read this table of data. So if somebody had told you, okay, go and read the table, the data in this table, and you'll be thinking, okay, where do I even start from? How do I probably be thinking about scraping a website, and maybe you're not so skilled with website scraping and all that, but you don't have to worry so much because Pandas allows you to simply pass these websites and it's going to extract the table. So it's going to ignore every other thing on this website and find all the tables there. So it finds if there are multiple tables there, it simply reads all the tables into a list. So you get a list of tables. So in this example, so I'm going to comment out this part so we can see what gets returned. So I've run the cell, I'm waiting for it. Obviously, it's just what it's doing is similar to what you do when you try to load the website. It loads the website and it gets a response of the content of the website. And it tries to parse the content of the website. Parse as P-A-R-S-E. So it tries to parse the content of the website. So this is what we get. And it might not look so as fanciful as what we've been getting before now. But that's because it's contained in a list. So there could be multiple items in this list. So let's, for instance, say learn. Let's try to get how many tables are in this. So how many tables are on the website, for instance. So here we get one. So there's just one table in the website. So since it returns a list, we need to use indexing to get that first, the first table in the website. So this is going to print out a nicely formatted table for us. And the same data we have on the website is what gets printed here. So in this other example, so you could be faced with some situations whereby the website simply, so I'm going to try to simply do the same thing I've done in this previous example with this before showcasing the alternative routes. Read HTML. So let's try to read this. So we're going to get an error. And here we get HTTP error. That means the program does not, or the function didn't get a successful response from the website. So typically 403, error 403 indicates that reading from the website is forbidden. Why that gets returned, I don't know. However, so I figured if we make slight modification to this, we'll get it done. So I'm going to delete this cell. So instead, the same thing it's meant to do when you call read HTML, which is send a request just like your browser will do when you type in the website. So send a request and get a response. So instead of having it do that for me, so I'm going to do it on my own. So here I'm importing the request module. Import the request. I have it installed. If you don't have it installed, remember to just pip install it. So, and I'm going to say request.get. So I'm telling it, get this, the content of this website for me. So and when you get the content of this website, when you get this website, when you get a response from this website, get the content of the website. So that's what this method.content is doing. So let me call it content. So I'm going to run this. So if you want to know more about this request module, you might just go to Google and just type in request module Python, and you get a host of things you can do with it, especially web scraping. So you can do web scraping with request module. Right, so this content is what I will pass now. I don't need this cell because when I was still playing around with it, so I'm going to delete it. So I also don't need this. I'm going to delete it. All right, I can safely delete this as well. So I have put everything together here. So here, this is the URL. So I'm saying,
Scraping.
okay. So I'll go back a little bit. So I said the request module can be used to scrape websites. So you can think of any website. You can basically get any content from any website using the request module and another module probably for parsing it. So if you want to know more about web scraping, you might just go on the internet and Google about web scraping. So focus here is to just use the request module to make it easy. For our read HTML to pass the covid19.ncdc.gov.ng website. So because we've tried to pass it before now and it gave an error. So we're trying to now make it easy to pass it. So now we use the request module to get the content. I could call this web content or something. Let me say web content to make it intuitive when we're going through it. Okay, so now it is this web content that gets returned from this request.get.content.
We
so
can't
this
see
web
the
content is what I'm
screen.
going to pass into this read HTML. So in the meantime, I'm going to
Sorry,
comment
we can't
out.
see the screen.
Somebody is saying something?
Yes, we can't see the screen.
Oh, sorry about that. Okay, so it's still the same part where I was discussing before it's cut off. Okay, so I've commented out this part. Now I want us to see what the web content looks like. All right, so I've sent the request. So I'm going to print what content gets returned. So this is what gets returned. Ideally, this is what your browser also gets. But the browser has been so designed to easily pass this content and display it in a very nice way for us to see. So this is what I'm now passing into this read HTML method. So now, there we go. I'm going to delete this. So it's still reading it here. So we have the data from the NCDC website showing states affected, number of cases on lab confirmed, number of cases on admission, number of discharged, number of death. So we check and we see we have how many records? 36 records. 36 records. And how many columns? Very easy to count. 1, 2, 3, 4, 5. 5 columns, excluding the index column. So this column is called the index column. So if you don't explicitly tell Pandas what your index is, it simply assigns index of 0, 1, 2, up to the number of records you have in your table. All right, so moving on. Here we'll be discussing how to select a subset of a data frame. So if you remember, we also discussed selecting subset of NumPy array. So here we can also select a subset of a data frame. So for instance, we're starting with columns subsetting. So getting subset of columns. So we don't want all the 4 columns. We want maybe 1, maybe 2, maybe 3. So here, in this first example, we'll say, let's select the number of deaths. So let's just guess, we want only the number of deaths to be shown. That's, we don't want other features, other columns of the data. So what do? We simply call the name of the data frame. Remember, the name of the data frame object is COVID-DF. And we use this square brackets and pass in the name of the table as a string or as is. In this case, the name of the table is a string. So if the name of the table is an integer, for instance, so you're going to pass in the integer. For instance, this could be probably column 0, column 1, column 2. You could name it column 0, column 1, column 2. So if it is named 0, 1, 2 as integer, so you have to use that 0, 1, 2 as is here. So in this case, the name of the column we are interested in is number of death. So we simply pass it in here. So here we will print out the type first. So the type, it tells us that it is Pandas series. So we can safely ignore pandas.core or anything. So it's simply a Pandas series. In contrast, let's see the type that the COVID DF data is. So this is Pandas data frame. It tells us it is a Pandas data frame object. So this is a Pandas series. So now let's print out the shape. Let's see what the shape is. So the shape is 36. So this tells us that there are just 36 records in it. That's simply in agreement with what we have here. So this one ranges from 0 to 35. So 0 to 35 means 36 items. So it's quite obvious that we actually have 36 states and FCT. So we're supposed to have 37 records here. Then a state is obviously missing from the records we have here. I didn't have time to investigate it. If anybody knows, you can simply say it. But obviously one state is missing from here. So maybe one state has not been reporting or has never reported.
Exactly. Cross River has not reported any case of COVID.
All right. Thank you for that.
NCDC has not reported a case.
All right. Thank you. So let's print out our series, the column we got here. So, and this is it. So this is the index row, and this is the column. But notice I use head here. So this head method is used to return the first few records in the data frame or in a Pandas data frame or a Pandas series. So a series is, I didn't mention, the difference in a data frame and a series is this. A series is just a column of records. Column of records that has index. So as we see here, this is the index and this is the column. So this is a Pandas series. So, and data frame is what we've been showing until this moment. So, and the head function or the head method simply returns by default top 5 records. So if I want more, I could say I want top 10. I pass in 10 and it's going to return the top 10. I could say I want top 20 and I could say, let's see, what if I pass 200, more records than there is? What gets returned? It simply returns the maximum without throwing an error. However, if you want to return all, so you don't need the head method to be called. So here, let's use the head and get just the top 5 number of deaths. Now, however, what if we want it to be nicely formatted as table, even though we're just getting one column of records? So let's see, how do we solve that? So I'm going to do the same thing here. The only difference is that instead of using a single square bracket and passing the name in, so I'm going to pass the name in as a list, so to say. I'm going to use double square brackets here. So, and it's going to, let me print it out, number of deaths. So I'm simply going to, so it prints it as a data frame. So, but it's really not necessary. Why do you want it in this? The disadvantage of series is actually very close to NumPy. So if you're reading just one column of record, it's much better to read it as a series because operations on a series is faster than operations on a data frame. Because series is very, very close to NumPy. And don't forget that I said NumPy offers a very high speed in terms of processing and operations. All right, so this is not advisable if you're reading just one column of record, except you want it nicely formatted like this. All right. So what else? In this example, let's select the number of cases that is lab confirmed and the number of discharged columns. So we want 2 columns, number of cases that is lab confirmed and number of discharged. So now you would agree that this is now a data frame. You can no longer read this as a Pandas series. So it has to be a data frame. So similar to what I did just above, I'm going to do that here, but instead of passing just one, I'm going to pass two as a list. As a list. So this looks like a list, right? List of two strings, number of deaths and number of cases lab confirmed. And I'm going to read the top 5 records. I got disconnected once again. I hope it just happened and it hasn't been long. Can everybody hear me now?
Yes.
All right, thank you.
Yes.
Okay, so here, let's see the shape as well. So this tells us there are 36 records and there are 2 columns. All right. Okay, so do we have any questions? It's 6 o'clock and we are not done yet, although we don't have much that's left to cover. We'll be done very soon. Any questions so I can very quickly answer? Okay, so I assume there's none. Okay, so I figured I didn't show this part. I didn't share my screen when I mentioned it. So this is the first 5 records, and this is the shape. So now row subsetting, we have seen column subsetting. What if you want to subset the rows? We want to get a subset of the rows. So this, here we will see how masking can be used to get subsets. So what is a mask? A mask is simply a series or a data frame of true or false values, or let me say true and false rather. True and false values. So in order to create a mask, you have to set a condition that will return true or false. So let's see, in this instance, let us create a mask of records with more than 30 deaths. So we'll go here, and in this data frame, we have number of deaths, right? So in this column, we want only records that have more than 30 deaths. So we'll create the mask and say, okay, give us COVID-DF, give us the number of deaths column where the number of deaths is more than 30, or where the record there is more than 30. So I'm going to print it out and we'll see a series of true and false values. So this mask is what we're going to use to subset our data frame. So in this example, it says selecting the records of states with more than 15 deaths. We want states that have more than 15 deaths. So we create the mask as explained above, and we use the mask to subset by passing it into square brackets just in front of the COVID-DF. So here we go, we have this. And if you check, every record here has more than 15 number of deaths. In the next example, let's select states with more than 250 confirmed cases and less than 500 cases confirmed as well. So we'll go and check number of cases lab confirmed. So we'll copy the name of the column. We'll come and we use it to create a mask. But here, there are 2 conditions that have to be met. The first condition is number of deaths must be greater than 50, or should be greater than 50, and the second is it should be less than 500. More than 250, I beg your pardon, not 50. So greater than 250 and less than 500. So we're going to use the ampersand or the and condition here. We can as well use AND, it will work, or we use this ampersand sign to create the condition. So don't forget to enclose each condition with a parenthesis, a bracket. So we use to subset our record. So here we're going to get only records with more confirmed cases than 250 and less than 500. So in the next example, we're selecting states with more than 250 confirmed cases and less than 500 cases. Am I not repeating the same thing? Okay, it is actually the same thing. Okay, so I'm going to delete this. And it's also the same here. But I can convert this. So there's something there's one example or one case I didn't mention here. The or case. Okay, yeah, it's there already. So I'm deleting this as well. So example 3, getting records of FCT and Lagos only. So we want to get the records of FCT and Lagos only. So we go to states affected. So under the states affected, we'll subset it by setting the condition to be FCT or Lagos. So, and in order to, the or condition can be passed using this pipe symbol. So this pipe symbol can work, and or as well can work. So let's use or. Oh, or clearly doesn't work here. So I was just to try it. So the pipe works. So I think consequently, and will not work here as well. I never tried it. I only assumed it should work. But since all didn't work, and would not work here. So it has to be this ampersand. So please take note. And here it has to be this pipe. Yeah. So we get records of Lagos and FCT only. Now let's quickly discuss creating plots with pandas before we bring down the curtain on today's discussion. So pandas plot function is an extension of matplotlib library. So matplotlib is what we'll be discussing in the next weekend. So we're supposed to have 5 weekends. The first weekend was Introduction to Data Science and NumPy. This weekend is Introduction to Pandas. The next weekend is Introduction to Matplotlib. The following weekend is going to be Introduction to some machine learning algorithms. And the final weekend, we're going to take some example or some practical building machine learning models. We're going to build some machine learning models. All right. So in this example, we're also reading HTML. We're reading from HTML. I said for this, we'll be using the data on air quality in this link. So you can click the link to see what the data looks like, but there's no need. I've simply read it into a data frame here. So let's see the data frame. All right, so this is what it looks like. I'm printing just the first 5 because I called .head on it. So it has 3 columns and an index. The index is called date time. So this is actually a classical time series data. So a time series data is data that is reported at a particular time. So there's time factor to it. For instance, when you take measurement of weather, so you'd want to report such measurements at a particular time. So whether at so time, the next time you take the record is going to be at so time. So if you continue to take such records, for instance, you could make a prediction of what the weather will be at a time in the future. So similarly here, they took record of air quality at 3 stations. The first station is Antwerp, the second is Paris, and the third is London. You can see there are some non-values there, so which indicates that either the sensor failed to read or for some reason the record is not available. So now let's create a time series plot. So we might want to see how the record or the air quality in these various regions vary over time. So let's simply call it, Pandas, when I say Pandas makes life very easy for data scientists, you have to believe me. By simply calling plots, it's going to print out a very nice tabular data for us. So here it is. Okay, I'm going to reduce the figure size to 12 by 12. Yeah. Oh, still too big for my screen. Let me say 10. So this is much better. So we get this time series data. We have 3 colors there: Station Antwerp, Station Paris, and Station London. And here we have the time, or the various time records to it. So you can see that intelligently it has grouped this time for us. If you look at the actual data, it's the records were taken in 1 hour intervals. So on these dates at 2 o'clock, and on this day at 3, here 4, 5, and so on. But it has been grouped here, and here we have 29, July 5, 2019, or rather May 7, 2019, then May 15, 2019, May 23, into 1 week intervals. If you actually take notice, every 1 or 8 days interval, rather, I think it's 8 days. Yeah, 8 days interval. So we can see very easily by simply calling plots. It plots out this for us. I mean, you can get away with not even passing this fixed size. The essence of passing this fixed size is to make it bolder, because the default size is quite small. So without knowing without having any skill, just by having a data frame already, you can simply plot a time series data. So in the next example, let's plot for just London. I mean, this is looking rather clustered. So let's plot just for London station. And we see it here. We can see that on a particular, or at a particular measured time, there is a spike here. So we might want to investigate what happened on that particular day. Was there maybe a disaster that led to maybe around the station where the measurement was taken, maybe there was an accident, a fire accident that led to smoke or fog or something in the air, or maybe there was just extremely bad weather that day. So we might also investigate that. So we see how it varies with time. Very nicely plotted out. So in this example, yeah, this plot method allows us to pass in a number of arguments. So in the next example, instead of the default plot here is a line plot. But in this example, we want to change the behavior of the plot method by passing in the kind of plot we want it to plot. So here we say we want it to plot a scatter plot for us. And we're still passing in the fixed size here. So I'm changing the fixed size to by 9. So here, because it's a scatter plot, because I'm putting it on the data frame has many columns. I want to specify the column I want it to plot. So I want it to plot station London on x-axis, station Paris on the y-axis. So let's go. And there it is. So we can see that for each, what it does is for each record, it plots the corresponding record for the 2 stations. So let me df. So for instance, station Paris is 9 here, and station London is 20. Let me take this. Station Paris is 25 here, and station London is 19 here. So it plots 25 against 19 on the chart. Here 27.7 and 19. So it plots 27.7 on one axis against 19 on the other axis, and so on and so forth. And that's what we have here. So here you might try to observe that, okay, there is a cluster here. This seems to indicate that most days, the whether the air quality ranges between, or it's usually within this range of maybe, I'd say 15 to 38, maybe 15 to 38, for instance. So let's try another plots called box plots. Box plots is especially useful to find outliers in your data. So we'll discuss more about all of these plots when we go when we discuss matplotlib. The goal here is to discuss ingesting data, tabular data into our program. So we won't dwell too much on what these various plots do. So we can see what box plots looks like. So this one has station Antwerp, shows that okay, there's just maybe one outlier. Outlier means it is outside the, okay, this line here indicates the mean. The topmost part of the data frame indicates the mode, and the we have the mean max. Okay, sorry, this is the mean, minimum, this is the maximum as well. So these are the outliers we have. So this one seems to have more outliers than the other stations. This one also has a significant number of outliers. All right, so moving on. We can also plot these three box plots as separate plots. So in this plots method, there is an argument called subplots. So if you tell it to plot the data frame as subplots, so it's going to try to plot each record as a separate chart. So it's going to pass, it's going to try to plot each column as a separate chart. So let's see it in action. All right, so in this example, we're actually plotting histogram, trying to see the distribution of values. So for instance, Antwerp, we can see that most values fall between this range. We can check the values at the, okay, so between 0 and 40, most values fall between 0 and 40. It's actually between somewhere greater than 0 in the case of Antwerp. And in the case of Paris, it's between 0 and the max here. So we can just see the distribution. And if we look, I think the one that is closest to a normal distribution is Station London. So this one looks like a left skewed, left or right? I think left skewed distribution, while this one is, well, not so much. All right, so that's all about plots. But before we round it up, we can also show how to save our plots. So say, for instance, you need to, you want to save this and be able to view it as a picture, as an image, or maybe you want to be able to export it and use it in maybe your Microsoft Word or upload it somewhere. So you can use save fig method. But in order to do that, we're going to import matplotlib pyplots, the pyplots function in matplotlib, or the pyplots module rather. So I import it and I give it the alias PLT. So I do the same thing here, but okay, here I'm plotting histogram, but just for Paris. So I'm saying, okay, df Paris. Another way to plot, instead of calling .plot, it also supports the specific argument. So you can say df.hist for Instagram, df.bar for bar plots, df.scatter for scatter plots, and a host of others. So if you prefer to do that, or if you want to just call df.plot and specify the kind of plot, the option is also available. So here I'm saving it and I'm passing a name and the directory. So here, because I wanted to save it in the directory I'm working in, I simply don't pass in the parent directory. So, or the base URL rather, the base directory. So here now, I run this, it visualizes it for me, and at the same time, it has saved it. So to see where it saves it to, I'm going to open up, excuse me, I'm going to open up my working directory here. So I'm trying to open up my working. Oh, I have to navigate to it again. Okay, so this is my working directory, day 3. So this is Paris air quality.png. So if I open it, so this is what it looks like. Okay. So we have actually come to the end of today's session. I'm sorry for taking more time than scheduled. I hope you will forgive me for that. I have a little practice problems before tomorrow's main assignment. So this is just meant to be practice problem. So as you revise today's class using this notebook, I've sent a copy of this notebook to everybody via mail, and it's going to be, this session is going to be uploaded on YouTube, and this is also going to be added to it in the description section. But if for any, it's going to also be added to the classroom. Yes, it's going to be added to the classroom as well. So I have 6 questions here. They are very easy. You only need to have followed this class to be able to complete it. So some I have added leading solution to it, and others not so much. So you're just going to answer all these questions, and they are very easy. Once you take your time to read through or probably go through what we've discussed so far, it's not going to take you more than maybe 20 or 30 minutes to get it done, maybe less even.